In this section, we're going to do our first full scheduling problems, and we're going to do that using priority lists. A priority list is a list of all the tasks prioritized in the order that we prefer to execute them. So if task X comes before task Y in the list, then it gets priority, so that when it comes down to a choice between the two, we would want to execute task X ahead of Y. Now, if X is not ready for execution, we're going to skip over it and move on to the first ready task after X in the list. The number of priority lists possible just comes from the number of tasks factorial. So say we had something like so we had something like 6 tasks to be completed. That would just be 6 factorial, and that would come out to be 720 different lists. In the process of doing this, the scheduling tasks using a priority list, we're going to call that the priority list model for scheduling. When we're doing these scheduling problems, it's important to remember that a processor or a worker can either be busy or they can be idle, and a task is one of 4 states. It's either ineligible, so not ready to be even started yet, it's ready, it's in execution, or completed. At each stage of the schedule, we need to keep track of this, and on the next slide, there's a record-keeping method for this. So here's a good way to kind of keep track of things as you're going through the problem. So in picture A, we have, when we circle a task, that means it's ready. So it doesn't mean we've started it, it just means that we can start it. In picture B, the task is currently execution, so it's after the circle and we put a slash through it. When we completely mark it out with an X, and like in picture C, that means the task has been completed. And then picture D shows a task that has nothing on it. That means it is ineligible for execution, so we cannot start that task yet. So here's our first full scheduling problem. We have a diagram on the top that shows us the precedence relation. So for example, task A and task B must be completed before we can move on to task D, and C must be completed before we move on to task E. Separately below is the priority list. The priority list isn't always necessarily going to follow the precedence relations. In this example it does, so it's just important to remember that the precedence relations do take precedence. So sometimes if it's something in a priority list is not ready yet, we have to skip over it and move on to the next thing that is ready in the list. And before we get started scheduling, let's assign some colors to each of these tasks, just so it's easy to follow. So we'll say that task A is red. Let's give task B the color blue. Let's give task C green. Give D purple. And I'll give task E orange. Now let's look at our priority list. Task A, B, and C, any one of those can be started. So I'm going to say task A is ready, task B is ready, and task C is ready. Notice on the end of the chart where it says n equals 2, that means we have 2 processors or 2 workers, so we can only fill out 2 of these rows. Since A is first in the priority list, we're going to go ahead and execute task A. So and task A takes 6 hours to do, so I'm going to just kind of shade in, and you can do this however you want. You can write out the letter A 6 times, whatever makes the most sense. So that's task A, and that's currently in execution. Okay, we can also give task B to worker 2. Now B takes 5 hours to complete, so we're going to shade that up only to 5 hours. Okay. So we can also say that B is in execution. Okay, so C is still ready to do. So let's look for the first worker to finish, and then we can give that task to that worker. So looks like worker 2 will finish task B 1 hour ahead of worker 1, who will still be working on task A. So we'll say that task B at hour 5 is completed, and then we can start task C. Okay, so in C takes 7 hours, so from hour 5, I'm going to be shading all the way to hour 12. Okay, so again, C is now in execution. While task C is being worked on by worker 2, let's look back up at worker 1. After hour 6, worker 1 finishes task A. So now we can say that task A is complete. And now that A and B are both complete, D is now ready, since A and B are prerequisites for task D. Since worker 2 is still working on task C at this hour 6, we can go ahead and give task D to worker 1. So we're going to start that here at hour 6. Now task D is only 2 hours long, so we're going to stop it there at 8. And we'll mark that task D has been in execution. Now by the time we stop task D at hour 8, so task D has been completed, task C is still being worked on by worker 2. Remember, that goes up to hour 12. So since C is a prerequisite for task E, we can't start task E until task C is completed. So we have no choice but to make worker 1 be idle from hour 8 to hour 12. So for those 4 hours, worker 1 has to wait for worker 2 to finish task C. So let's say they're idle, and then we get to that 12th hour, and task C is now complete. So right now we're at hour 12. Now we can officially say that task E is ready for execution. And at this point, it really doesn't matter who you give it to because it's the last task anyway. So we can give that to worker 1, we can give that to worker 2. It's still going to be the same amount of total time in the end. So let's say that since worker 1's already had a break, we'll give that task to worker 1. So task E is 5 hours. So we're going to start that here at hour 12, and we'll go up to 17. So now task E is in execution, and then at hour 17, E is finished, and all tasks have become finished. So we can say right here that our finishing time is 17 hours. And notice the idle time that we had. So processor 1 with 4 hours of idle time, and processor 2 with 5 hours. So sometimes a question may ask you to also give the idle time. So we had 4 and 5, so we had 9 hours of idle time. So now we have the same problem, same diagraph, except we have switched around the priority list. We still have only 2 workers here, and let's see if this makes a difference in our finishing time. Once again, I've color-coded tasks A, B, C, D, and E to make this a little easier. So in our priority list, task E comes first, followed by task D. Now the problem here is that neither of those are ready for execution, so we have to skip over to task C, task B, and task A. So this time, well, in the last example, A was ahead in the list. This time C is ahead. So we're going to prioritize task C and go ahead and get that task started. So we're going to give that to worker 1, 7 hours. Okay, and task C is now in execution. While worker 1 is working on task C, we can give the next worker task B, which is going to take 5 hours. Okay, so task B is also in execution. At hour 5, worker 2 finishes task B, so B is complete, and we can go ahead and give worker 2 task A. And A takes 6 hours, so it's going to bring us up to hour 11. At hour 7, worker 1 finishes task C, so we can say that that's complete. So now that task C is complete, task E is now ready to be started. And we can go ahead and give that to worker 1. So starting at the 7th hour, E takes 5 hours, so that's going to take us up to hour 12. And now task E is in execution. So before task E becomes finished, task A becomes finished. Oh, we forgot to mark that earlier, so task A was in execution. At hour 11, task A is complete. So now that task A and B are complete, task D is now eligible to be started. While worker 1 is still working on task E, at hour 11 we can give task D to worker 2, and that only takes 2 hours, so from 11 to 13. Okay, and so now task D is in execution. Let's look at hour 12. Task E is completed, and then there's nothing else to be done, so worker 1 will just be idle for 1 hour, and the entire project will be complete at hour 13. So we'll say fin equals 13, which was better than in the last slide. So the way you change up the priority list really does have a lot to do with how efficient you can create the schedule. And we'll say 1 hour of idle time. So now we're going to see if we can do any better with 3 workers. So notice now n equals 3. The priority list is the same as on the last slide. So let's read across our list again, and notice again the same color coordination. So it's still E, D, C, B, A. And this time again, E and D cannot be started yet, but C, B, and A are all ready to be started. So again, since C is first in that list that's ready, we're going to start with task C. I'm going to give that to processor 1. So NC takes 7 hours. Alright. So now we can say C is in execution. Task B is also ready. That takes 5 hours. So we'll shade that up to hour 5. Okay, so B is in execution. And now we have a third worker, so we can give task A to the third worker. Okay, and so task A will now be in execution, and task A takes 6 hours. Okay, so this time a little bit more going on at once. Let's look at the first of those tasks to be finished. It looks like task B is finished first, so we're going to say that that task is now complete. Now, we can't go on to task D just yet because we still need task A to be finished. And notice that task C is still being worked on, so we have no choice but to let worker 2 be idle just for an hour there. So now we're at hour 6, and notice that task C is still in execution, but both tasks A and tasks B are complete at this point, which opens the door for task D. So it doesn't really matter, we can give that task D to worker 2 or worker 3. I'm just going to give that to worker 2. Okay, so that starts at 6 hours, and task D is just a 2-hour task, so all the way up to hour 8 there. And task D is now in execution. At hour 7, task C is finally completed, so we can scratch that one out. And now that task C is completed, E is now ready to be started. And at this point, we can't give task E to, if we're still at hour 7, we can't give task E to worker 2, but we can give it to worker 1 or worker 3. And it really doesn't matter. Task E is 5 hours, so 7 plus 5, so that's going to go all the way up here to 12. Or if I wanted to give worker 1 a break, maybe I could give that instead to worker 3. It would still end at hour 12. Okay, so now task E is in execution. Notice that hour 8 task D is completed, and there's really nothing else to be done, so the other workers are just going to have to wait for worker 3 to finish up task E. At hour 12, that becomes finished. And we're going to stop there. So our finishing time here is 12 hours. So 1 hour better than when we had only 2 workers, but the downside is that there's a lot of idle time. So if somebody's getting, for example, paid to do the work, they're getting paid to just kind of sit around for quite a bit. So this time we had 11 hours of idle time. So ultimately we do want to make an efficient schedule and get things done quickly, but we also do want to minimize the idle time as much as possible. So now we have an example where we really have to start from scratch. All we're given are the precedence relations in a table and the amount of time for each task. So first we're going to draw a diagram, and then we're going to use that, and we're just going to make our own random priority list, and then go from there to schedule the tasks. It looks like A, B, and C can be started without precedence, so we'll go ahead from there. So say starting point here, and we can either go up to A, we can go to B, and that's a 4-hour task. We can go to C, 7-hour task. Alright, D cannot be completed unless A is completed. So we have a precedence relation from A to D. D is 6 hours. E also cannot be completed unless A is completed. So E is 5 hours. We'll draw the precedence relation from A to E. Okay. Next, F cannot be started until B is completed. So we'll put F right here. And that is 5 hours. And lastly, G cannot be completed until tasks D and E are both completed. So we'll draw the precedence relations from task D and E over to task G, which is a 4-hour task. All right, and I think we've got everything now, so we can all combine it. So everything leads to G, to F, and to C. So we'll take all those and put them to one common ending point. So now what I've done is create a priority list just kind of randomly. So just for this time, A, B, C, D, E, F, G. And let's go ahead and say that there are 2 workers for this problem. So to start off, let's look at which tasks are ready. It looks like tasks A, B, and C are currently ready. Okay, since A is first on the list, we're going to start with task A. I'm going to give that to worker 1. That's going to take 3 hours. Alright, so now A is in execution. We can start task B. I'm going to give that to worker 2, and task B takes 4 hours. Okay, so now task B is in execution. Once task A is completed by worker 1, we can go ahead and give that worker task C. So we'll say task C is in execution. And task C is going to take 7 hours. That's going to bring us all the way up to hour 10 there. Okay. So now that task C is in execution, let's look back at hour 4, where task B is complete. I also forgot to mark that task A was complete, so now task B is complete. Now that task A is complete, that makes task D ready, and that was from hour 3, but task C was still ahead in the priority list, so it's good that we went ahead and put that down. At hour 4, when task B is completed, that allows us to start task F. And sorry, I almost forgot that A also leads to E, so task D and E are ready. And now at hour 4 that task B is complete, task F is also ready. The only thing that's not ready yet is task G, because we need to complete tasks D and E first. So while C is being worked on by worker 1, let's go ahead and give task D, we're going to give that task to worker 2, and that's a 6-hour task. So that's going to take us all the way up to 10. Okay, so task D right now is in execution. At hour 10, task C is complete, and task D is also complete. Okay. So now we've kind of evened it out, and tasks E and F are both ready, and it doesn't really matter who we give those to. So I'm just going to give task, let's say we can give task E to maybe worker 2, and task E is a 5-hour task, taking us up to 15 here. So now task E is in execution, and let's give task F to worker 1. And task F is also a 5-hour task. All right, so both of those end at 15. Forgot to mark here that F is in execution. Okay, so now at hour 15, F becomes complete, and so does E. Now that E is complete, D and E are complete, G becomes eligible. So now task G is ready. And since it's evened out, it really doesn't matter who we give that to. We can give that to either worker. So I'm just going to give that task to worker 1. And task G is 4 hours long. So from 15, it's going to go all the way up to 19. Okay, and then in the end, so G's in execution. There's nothing else to be done, so worker 2 is just going to have to wait. And at hour 19, G is complete. So we'll say our finishing time here ended up being 19 hours. And with 4 hours of idle time. So that's not too bad. And again, if you were to order the priority list differently, we might have had a different outcome. If you're following along with the guided notes for this lesson, I think there's 2 more examples to follow this. So if you would, please try those on your own, and feel free to change up the priority list if you want. And that way, when we get into class, you might have different answers from your classmates, so we can discuss which priority list is best and why, and which would be a good lead-in to our next section.